Have you ever looked at a skyscraper and wondered how it all came together? From the first soil test to the last coat of paint, there's a precise sequence that turns bare ground into a finished building. In this episode of Sketchy Engineering, we'll walk through the entire process step by step. Before design even begins, we need to understand the ground we're building on. This is done by drilling boreholes and taking soil samples, but there are also other methods like cone penetration tests or standard penetration tests. These tests reveal the soil's mechanical properties and guide the foundation design. Once the design is ready, heavy machinery clears the site, stripping away topsoil and any unsuitable material. Often, we place a hard stand, also called a working platform, so heavy vehicles and cranes can operate without sinking into soft ground. Temporary site facilities are brought in, usually with truck cranes, site offices for engineers, lunchrooms, and amenities for the construction team. For tall buildings, basements are common and often used for car parking. To dig a basement safely, a retaining wall is built before excavation. One method is using perimeter piles, drilling into the ground, placing a steel reinforcement cage, and filling it with concrete. This is repeated around the site to create a wall that holds back the soil during excavation. Depending on the soil, other systems like sheet piles, soldier piles, secant piles, or diaphragm walls can also be used. The piles or diaphragm walls act as retaining walls, preventing the soil from collapsing into the excavation. In tight spaces, conveyor systems may be used to move the spoil to trucks for disposal. If the groundwater level is above the basement's bottom, it needs to be lowered during excavation. Deep well systems pump the water away, reducing the phreatic level so work can continue in dry conditions. Depending on soil and groundwater conditions, the design may call for shallow or deep foundations. For high rises, piles are usually needed to reach stronger layers far below the surface. Piling rigs drill the piles, which transfer the building's load through side friction and end bearing. On top, pile caps distribute the load from the structure into multiple piles. With foundations complete, a tower crane is installed to lift materials across the site, and a concrete placing boom is set up for efficient concrete pours. Most high-rises have a central core, often housing elevators and emergency stairs, that provide stiffness against wind and earthquakes. Steel reinforcement is pre-assembled on the ground or off-site, then lifted into place by the crane. Formwork is also partly assembled before lifting to save time. Finally, concrete is pumped from trucks through the placing boom into the forms to cast the vertical elements. Scaffolding and props are then placed to support the slab formwork. Reinforcement steel for the slabs is laid, then the slab is poured with concrete using the boom. This process repeats, floor by floor, until the top is reached. Formwork is stripped once the concrete reaches the minimum strength, which could be anywhere from 3 days to 2 weeks, allowing it to be reused higher up. This optimizes formwork usage, reducing rental costs and storage needs. As the upper structure grows, lower floors are fitted out with partition walls, plastering, drywall, and other works according to the plans. Overhead services are also installed: electrical, HVAC, water, drainage, and fire protection, often alongside facade installation and suspended ceilings. This staggered approach keeps multiple trades working at the same time. Once systems are in place, finishing works progress from the ground floor upward, installing doors, windows, flooring, paint, and fixtures. Outside, driveways, footpaths, ramps, and landscaping are completed, grass, trees, and lighting bringing the surroundings to life. In the final phase, systems like fire alarms, lighting control, HVAC, and CCTV are tested and commissioned. When everything is operational, the building is handed over to the client. And that's how a skyscraper grows from dirt to skyline. Thanks for tuning in to Sketchy Engineering. And if you learned anything new, go ahead and like and subscribe. I'll be dropping more videos like this.